Okay, Bismillahirrahmanirrahim. I formally welcome you all to this mathematics class for bioinformatics. This is just a test lecture as a recording. So in 10 to 15 minutes, I will try my best to summarize this topic. And today's topic is eigenvalues and eigenvector, which is the most important topic in this field and in bioinformatics, and even for the research point of view as well. So the first question that comes into my mind, or in every student, that what is eigenvalue and what is eigenvector? So in the last lecture we have almost done half of the part, but now we will see that how to do this complete job. So what was the eigenvalue? Eigenvalue was just a constant, a lambda, which satisfied a certain equation, which was Ax is equal to lambda x, where A is a square matrix and x is a vector and lambda is a scalar. So the idea is this, that you would like to find a scalar value lambda in such a way that it satisfies this equation. And in the last lecture we have seen that we can convert this into a system of equation which will be homogeneous as well with the help of this identity matrix. So what we are trying to do, we will move this lambda x on the left hand side and then we take this x common, but keeping the fact that since A is a matrix, so we need some matrix to minus it. So we take identity as our identity matrix and then we multiply with a scalar and we get this matrix. Now what this is actually, this is a system of homogeneous linear equation and we have to find this lambda and x. This lambda is actually our eigenvalue, which represents a number which satisfies this equation. So in reality it means that we are going to find a number which is representing the same quantity which this matrix A is doing. Since A is a matrix, so it is applying to a vector, so we will get some vector. So here it is a scalar. So the role of this matrix is almost the same as the role of this scalar here. So this is the idea. So instead of keeping the burden of this matrix, we will just see how this lambda looks like. If it is greater than 1, if it is less than 1, if it is equal to 1. So it has some biological or real life meaning as well. So this is what we are going to do. Now the next question that comes, that how we will find it. So since it is a system of linear equation, so we will try to convert it that. So what is the idea? So let me write this something on the board as well. So this was the equation, Ax is equal to lambda x. So we subtract it. So this is a homogeneous system. So this homogeneous system is like you can say a Cx is equal to 0. So for the solution of this, we know that the determinant of this C must be 0. So we apply the same idea here as well, that if we want to find a non-trivial solution, then determinant of this A minus lambda I must be equal to 0. So now the question is that how we find the determinant. So since we know very well that if we are 2 by 2, 3 by 3, 4 by 4, any determinant of the matrix given, we know how to solve it. So this is very simple. If we try to solve it, what is going to happen? There will be an equation in lambda. So equation in lambda means, for example, it is like A1 lambda square plus B1 lambda plus C1 is equal to 0. For example, this is the equation that we will get when we open the determinant. So now we will solve it. We will get over lambda 1 and lambda 2. If this is a 2 by 2 system. Similarly, if it is a 3 by 3 system, 4 by 2 system, we will see that what is going to happen and when we simplify this. It is not necessary that if we have a 2 by 2 system, then we have a quadratic. It may happen that this lambda square coefficient will be 0. So it depends on what is going to happen here. Okay, now we will do one example so that we know how to solve it. Okay, so we consider an example where we have given this P is equal to 0.9925 and then 0.0025 and next is 0.0075 and next is 0.9875. So this is the matrix we have given in the last example, and the question is this. So this is the question. So now we will try to solve it. How to solve it? We need an equation which is known as the characteristic equation. And this is what? A minus lambda I determinant